We've used this term freely, fear. Now let's shift gears and talk about this agent zero model, where some mathematical neuroscience of fear is actually included, okay? And I published this book, Agent Zero, Toward Neurocognitive Foundations for Generative Social Science, which I believe the social sciences include epidemic behavior and all sorts of other things. Although, as I said before, there are other targets like neoclassical economics. And the book was published by Princeton Press, and then another article by myself and Julia Chellan published by MIT Press. So we've been persisting in this. And then we have, as I told Benjamin before, we have a bunch of work underway where the epidemic models really do have agent zero, not differential equations, although it can also be mathematized. But let's talk about this. And as I say, it's part of a larger agenda on generative social science. And here the idea really is that what do you mean by an explanation of a social phenomenon, like segregation or market dynamics or Pareto distributed wealth distributions and other macroscopic regularities? What do you mean by an explanation of segregation or these other sorts of things? And I think what we mean by it is that you show how those patterns, social phenomena, could emerge on timescales of interest to humans in a population of cognitively plausible agents. Obviously a fraught phrase that we'll come back to. But you're building micro worlds, little m's, that generate the macroscopic explanandum, right? And the motto is negative for me. If you didn't grow it, you didn't explain it. For any x, if you didn't grow x, you didn't explain it. But it's not the converse. There might be many ways of growing it. It's not true that anything that grows it is really legitimately explanatory. I mean, they could get into position randomly, for example. But it's very different than the kind of dominant notions in the social sciences. I mean, it's very different from furnish a game in which the patterns are Nash equilibrium, as in game theory, or furnish a functional with respect to which the trajectory is an extremal, as in Gary Becker's famous work, or furnish a regression relating aggregate variables, which obviously doesn't include any account of the micro-macro relationship. All right, and I think explanation is quite different than prediction, and I've written quite a lot about this, but this is the basic idea. It's like, you want to understand how things happen, show me how they could arise in some population of cognitively plausible agents. All right, and again, we can argue about this phrase, and obviously should, and there's a million ways to think about cognitive plausibility, but it seems to me that, certainly, and a few would deny that humans have emotions, one of which is fear that matters in many instances, like the ones we'll talk about. They also have some deliberative, and emotions can be unconscious. You can acquire fear without knowing it at all, and we'll talk about this. So it's not conscious or rational or anything else. You're not maximizing anything. You're just, your neurochemical architecture produces this emotion, all right? And we can measure this in crude ways with fMRI and so on. And I'll come back to that. So one axis of the cognitively plausible agent space would be some affective module, an emotional module. Second, yes, we do reason, but as Hume said, reason is a slave to the passions. And although we do reason, we have bounded deliberative capacity. We usually have imperfect information, and we do erroneous statistics on it. We make all sorts of mistakes: base rate neglect, anchoring, framing effects, asymmetries between gains and losses. All of this stuff that Herb Simon and Daniel Kahneman and the behavioral economics group and Paul Glimcher of the neuroeconomics movement have all established this in great detail. So yes, we're going to include a deliberative component, but we're not going to make it Homo economicus or the canonical rational actor. We're going to try to respect some of these empirical observations about how people behave. And emotionally driven, boundedly rational agents are in networks, and they affect each other socially. So there's emotions, there's deliberative capacity, and there's social connection. And all of those might matter. And one candidate that includes these dimensions in the span of this basis, if you like, is agent zero. Okay? So This creature is endowed with distinctive, affective, deliberative, and social modules, each of which is a real valued function on the unit interval, defined on a stochastic stimulus landscape, which is stimuli that could be aversive, which they might take track of statistically. And each of these modules is grounded in contemporary cognitive neuroscience. Simplified version, but at least it has some actual neuroscience basis, unlike the kind of bulk parameter transmission picture that we've been looking at. And the internal modules interact within the agent to produce observable behaviors like flight or retaliation or vaccine refusal or what have you. And when you put multiple agents of this kind together, they generate, as I show in this book and in subsequent publications, a lot of collective dynamics in the fields of health, but also conflict, networks. I mean, these agents build their own networks and take them down endogenously. I'm not positing a topology and releasing a test particle into it. The agents build their networks based on homophily of fear. And that changes over time. And so the network structure can change over time, all right? Economics, as I've been discussing, social psychology, even law. We have a simple model of jury dynamics where, you know, alone, every juror would acquit. Together, they unanimously convict. Things like this that are perverse and important and interesting. And the idea, as I say, is very humble. The modules, you know, the modules are crude. And I say, look, the game isn't to get the modules finished, but to get the synthesis started. The modules we can improve and should improve and look forward to improving. They're all provisional, but the idea is what's the right picture? What's the right wrong model, okay? And I think Agent Zero is a very fertile wrong model, but it's a formal one, and this is very important. I mean, there's lots of empirical criticisms of the rational actor in economics, game theory. As I said, the rational epidemics tradition is in this, rational epidemics is in this tradition. But, you know, gripes, counterexamples, even decisive falsifying experiments don't change scientific practice in fields like economics. I think Paul Samuelson said, you can only beat a model with another model. And so we need explicit formal alternatives to the rational actor. It's not enough to say, that doesn't work. They'll say, right, it doesn't work, but what do you got? And I'm saying, well, maybe this. So Agent Zero is an alternative. And as I say in the book, there's a differential equations, half of the book, and then there's an agent-based half of the book. But the subtitle is Toward Neurocognitive Foundations for Generative Social Science. So we talked about generative social science as an enterprise. What's the neurocognitive piece? So let's flesh out the fear module. I'm happy to come back and do a full talk on Agent Zero, but I didn't want to take all of our time. So I'll talk largely about the fear module and how that's implemented, okay? So again, we're thinking of vigilance and complacency. So we care about fear acquisition and we care about fear extinction. So now I will butcher what little neuroscience I know and talk a little bit about this fear apparatus. And again, I've had the benefit of many consultations with real neuroscientists here at NYU, Joe Ledoux, Liz Phelps, and others. So the classic conditioning, fear conditioning experiment, this is an fMRI of the subject's of brain. And in this panel is her amygdala, all right? And orange is a bold signature. It's blood oxygenation, which is really recruitment of blood to the amygdala, which is a crude measure of amygdalar activation. And we know that the amygdala is not, functionally specific to fear, but is, is strongly implicated in the fear apparatus. So the classical conditioning is that the subject is wearing a shock cuff, all right? And he gets an aversive shock sometimes, all right? But in the first instance, I show the subject a blue light and no shock. You get nothing. The amygdala doesn't do anything because there's no aversive stimulus. So blue light alone doesn't provoke any response, whatever. The shock cuff alone produces the response. It's like, yike, that's bad. And I freeze, like when I throw a snake in your lap or do other things that are scary. So there's a surprising aversive stimulus that does recruit blood to the amygdala and stimulates responses associated with fear. endocrinologically, in terms of pupil dilation, and a million physical metrics, including this amygdala thing. All right? So blue light alone, nothing. Shock alone, amygdala. Now I start pairing them. Blue light shock, blue light shock, blue light shock, blue light shock. And after I do this enough, I show the blue light alone, and the amygdala lights up. This is the state in which the person has been conditioned to associate the blue light with an aversive stimulus. And blue light alone recruits the amygdala, okay? And one of the famous models of associative learning is this Rescorla-Wagner model, where it says the gain in associative strength is some constant registering the surprise and salience of the aversive stimulus times maximum associative strength minus the last time you got the stimulus. Okay? All right, so if it's not surprising, then you're used to it and nothing big happens. And if it's not salient, the shock's too weak, you don't really notice. So you have to have surprise and salience, which is why surprise is so important in the case of financial panics and vaccine adverse effects and the rest of it. Expectations matter a lot in behavior. All right? And again, this is the picture for this really, really simple, non-homogeneous first order ODE, or difference equations, whatever you like. All right? And the full trajectory with extinction, the way you arrange extinction in the Rescorla-Wagner model is stimulus stops when this is set to 0. And in that case, it decays exponentially. So the picture is, you know, the full affective trajectory with extinction. So you have this vigilance phase where you're learning, but then the stimulus stops and the association decays. And in the classical model, it decays negative exponentially, or at least it's concave down, then concave up. All right? And if you look at animal models, animal experiments on rodents and all vertebrates, you get this profile. You know, they get the conditioning phase and then they extinguish. And if you'd like to do, you know, if you like Heaviside unit step functions, you can combine the whole thing into this expression. And what I like to say is, we do not fear what the rat fears, but we fear how the rat fears. We actually fear many of the same things, by the way. But in any case, this is the crude, very, very simple picture that I've used in Agent Zero. I've equipped Agent Zero with this fear learning and extinction apparatus, for better or worse. All right? Now, we're saying it's contagious in these models. And fear contagion also has a long history. Adam Smith, Gustave Le Bon, huge literature on financial panics and so on. Now, the coupled contagion models show, I think, that it's a fruitful modeling postulate. But is there any neural basis for that? Is there any license to say the thing's contagious? And yeah, there's a big literature on this, but including John Cassiopo's work called Emotional Contagion. And lots of other work on it. But again, to be back at the fMRI level, one very suggestive experiment conducted by Olson Nearing and Liz Phelps here at NYU is this one. Here's the original experiment where this agent is hooked up to the apparatus, wearing a cuff, and you get blue light shock, blue light shock, blue light shock, light alone, his amygdala lights up. But this is panel A. Panel B is a different subject who's not wearing a shock cuff at all. He never gets any shocks. He observes the conditioning of subject 1. He watches the blue shock parents, blue shock light, blue shock light, blue. Then he's shown the blue light and his amygdala lights up. So I can learn to fear the thing without being subject to it, at least. So I can learn to fear fire by watching you get burned on the stove. That's a useful thing, of course. But the downside is also very clear. You can acquire, and unconsciously, all kinds of baseless fears by watching people be afraid of different ethnic groups or different races or what have you. You can acquire all sorts of nefarious and ugly fears without basis. And Agent Zero does this very nicely, as we'll see in a minute. Okay, so the affective module of Agent Zero is a somewhat generalized version of this model. And emotional contagion through network weights. that are functions of affective homophily in the book. The deliberative module, agent zero is a relative frequentist over some memory window, imperfectly informed, boundedly rational in the tradition of Herbert Simon, Daniel Kahneman, Paul Slovic, and all of these others. And the social module exhibits conformity effects in these endogenous social networks. And again, there's neuroscience, very interesting neuroscience and fMRI work on conformity and rejection, and that it stimulates sensory pain centers. It really hurts to be rejected in the view of these neuroscientists. All right. And, you know, again, I can come back and we can go through all of this about agent zero, but the idea is the action is binary and you act if your total disposition to act exceeds some threshold. And the disposition is your affective level, your fear, plus your deliberative appraisal of the threat, plus the sum of weighted, this is your solo disposition. This is what you do alone. If that's greater than the threshold, you will act in some binary way. And with others, you have your solo disposition and the sum of their weighted solo dispositions. All right, and again, I'm trying to keep the parameters really minimal. There's one threshold for everybody. I think it's cheating to have different thresholds. And the V of t solves this differential equation, but in practice, I've just used K for all of this crap. I wanted to let S curves happen, so I multiplied by V to the delta. But in the book, and also most of the work, I just use one parameter, K, for this learning, combined surprise learning rate, all right? And the deliberative component is the moving average of the local relative frequency of aversive events. So the memory is a third parameter, and the weights, as I say, are endogenous. Your weight is a strength-scaled affective homophily between you and others in your network. Okay, and I'll show you how this really unfolds on this landscape, if I may. All right, so here are three agents of the agent zero type. They're on some space. Think of these as occupying forces in a military occupation of some foreign country, all right? And the population are these yellow patches. I've just made them different colors to distinguish them. Each patch is an individual, all right? And agents have vision of, you know, their von Neumann neighborhood. They have some sensory radius, okay? And these are aversive stimuli. Think of them as ambushes or attacks on these guys, these occupying forces. And there's an area where there's a high attack rate. And these are surprising, salient bad things, you know, ambushes or something. And so their fear conditioning on these aversive stimuli, not consciously, but they're developing fear. And they're also making a statistical estimate of the likelihood that a randomly selected yellow site will blow up on them through a computation of relative frequency over some memory window within this sampling radius. If that all exceeds the threshold, then they blow up sites, they retaliate. And these are these black retaliation things, okay? So there's two zones, an active zone and an inactive zone. This agent is never subjected to any aversive stimulus whatever. And he doesn't detect any because their vision is too small. He doesn't see any, he doesn't experience any. The only thing he has is network connection to these other agents who are subject to the stimulus, all right? But his disposition alone to retaliate is zero. But through this process of dispositional contagion, he blows up his village too, all right? And obviously these are all, any of these funny little movies are they're just one sample path of a stochastic process, and you'd never publish one run of these things. But they're suggestive, and of course in the actual work we don't do this. We do run many, many runs, and even compare them to data, as I was saying before. So here's one run where an agent joins the lynch mob, even though he's had no aversive experience with Black people, whatever. Okay, why? Because his total disposition exceeds the threshold, even though his solo disposition does not. All right, so he takes action in the group that he wouldn't take alone. And what's more interesting is that he may be the only agent with that ordering, in which case, despite being negatively disposed in this net sense, he actually goes first. So here's the same agent He has no direct stimulus. And not only does he doesn't just join the lynch mob, he leads the thing through this process of dispositional contagion. And in many ways, I think that's the most arresting run, because it also suggests a critique of the literature on the great man theory of history. I mean, most people would say, why does he go first? Well, he's the most committed to his course, and he's the most courageous, and he's a leader. No, he's just the most susceptible to dispositional contagion. And as Engels said, if not Napoleon, another would have been found. And of course, Tolstoy is the great advocate of this perspective, and I talk about him a lot in the book, that there are no, the great man theories, that we are all differentials of history. And I think of Tolstoy really as the first agent-based modeler in spirit. And there's lots of quotations of Tolstoy in my book. I always say data is the poor man's literature, or statistics is the poor man's literature. All right, they can do other things like flee. Here, this agent wouldn't flee, and it could be flee your portfolio, flee your bad diet, flee your Chernobyl contaminated area, or flee high disease areas. But these agents do flee, and through the same process, they get this other person to flee. And again, these are just toy models, but they embed this simple apparatus at least. Okay. And there's another one of these runs where you know, as I say, it's in the book, but it's a case in which there's a jury trial and there's a pretrial phase where people are in the public square hearing. Their stimuli are assertions that, you know, O.J. Simpson is guilty, O.J. Simpson is innocent, O.J. Simpson is blah, blah. And they're developing some associative strength on this opinion. Then they're selected for the jury and they get a different stimulus pattern from the defense and the prosecution, but they still haven't talked to one another, but their dispositions have changed. And now they're sequestered in the jury room where dispositional contagion operates fully. And, you know, in this case, they can arrive at a unanimous guilty verdict where before the jury phase, they would all have acquitted. So in that case, they all betray themselves, right? Everybody has this ordering where alone they'd acquit, together they unanimously convict. And I think of that as universal self-betrayal, which is another one of these phenomena that I think is, you know, of real depth and interest about just the human condition. Okay. And again, we've been doing this with one agent, but here you can have large scale activation in the southern region where there's no aversive stimulus. The only aversive stimulus is in the north here, but these are people connected to one another by these networks, and you can see that you get large-scale activation in an area where there's no stimulus at all, and the height is the level of disposition. And if they're above their threshold, they wipe out sites in black. But you can get large-scale activation, you know, again, in areas where there really is no actual threat. And I, you know, maybe it's impolite to read your writing, but I like this statement. I say, the overall picture of Homo sapiens reflected in these interpretations of Agent Zero is unsettling. Here we have a creature evolved, that is, selected for high susceptibility to unconscious fear conditioning. Fear, conscious or otherwise, can be acquired rapidly through direct exposure or indirectly through fearful others. This primal emotion is moderated by a more recently evolved deliberative module, which at best operates suboptimally on incomplete data and whose risk appraisals are normally biased further by affect itself. Both affective and cognitive modules, moreover, are powerfully influenced by the dispositions of similar, equally limited and unconsciously driven agents. Is it any wonder that collectivities of interacting agents of this type, the Agent Zero type, can exhibit mass violence, dysfunctional health behaviors, and financial panic? And we have work going on in all of those areas using this simple picture. Okay, plans are to, we have several NSF proposals to deepen and extend agent zero. One of these is to populate with Courant large-scale models with these agents. And I just wanted to show you the sort of large-scale modeling that's possible. Here's a US scale model with 300 million agents. And we published this in the Transactions on Modeling and Computer Simulation, which is sort of the journal of record on computer simulation in this area. And we start the thing in Los Angeles. As a New Yorker, I always start everything bad in Los Angeles. And the color code is black is healthy, red is sick, blue is recovered. This was done for NIH, and they didn't care if you recovered or died. They just wanted to know the case fatality. They just wanted to know the infection level, and they could apply their own case fatality rates. But we applied one. And here's, just as a software engineering proof, starts in LA. And we have every zip code in the United States. There are 30,000 zip codes. So there's if the matrix of zip code to zip code travel matrix is 900 million cells. And you can see how things unfold with no interventions. It gets everywhere. It can get quite, get there quickly. But you can play a million games with this. When should I close schools? Is it too late to do a quarantine? Who should have priority in vaccinations? And so forth. And the idea is, let's populate models at this scale with these more plausible agents. And at a higher level still, we published a global model with 6.5 billion individuals. And again, above some level of saturation, I think you could hand this off to ODEs. I mean, it becomes pretty well mixed, pretty well spread. But again, it's an agent-based computational model. I published a piece about it in Nature. And another thing, here we start, this was stimulated by bird flu, again, was done for NIH, and it asked, if some, the bird flu was scary because it kills people, but it wasn't very contagious. We didn't observe any human-to-human sustainable chains of transmission. And of course, the fear was that bird flu H1N1 would recombine with seasonal flu H3N2 to produce a variant that was the worst of both worlds, highly transmissible and highly deadly. And what if that emerges in Asia someplace? And they said, please play that out. And so we did. And here's one of, again, a zillion runs where it gets around the world very quickly. Something like SARS was on, I don't know, 4 or 5 continents in 24 hours. I mean, with international air travel, it's a well-connected system and things go quickly. And again, you could ask, do travel restrictions actually make sense? If things are already in the United States and underway, is it pure cost to put on a travel ban in terms of trade and economics when it doesn't buy you much epidemiologically after the thing is already present and underway? So you can play these games too. And we did some modeling of Ebola in this connection. All right. So again, these are the sorts of models we're interested in. I'm interested in a more cognitively plausible agent grounded in some serious neuroscience, a la Agent Zero or the many extensions of that model that are possible. And I think this theoretical interest in social science and displacement of the rational actor with a more acceptable foundation for generative social science. But I also want to populate these large-scale epidemic, disaster, civil violence, other models with agents of this type and get a better representation of how things actually work and hopefully mitigate some of the worst consequences in these cases like pandemics. So that's what I'm up to. And I welcome your feedback, your suggestions, and I'm very interested in collaborating with people on this to look at these mathematizations of these agent models and reaction diffusion generalizations of the ODE models, all sorts of things. So I really consider you colleagues, and here's my email, and I'm delighted to follow up on everything. So please, any feedback you'd like to give is welcome, and I thank you for your attention.
Thank you so much, Joshua, for this very instructive and complete, amazing talk. We have a couple of questions. So Karin raised her hand. So yeah, please go ahead, Karin, if you want to ask your question.
Okay. So thank you very much for this very, very nice work and reflection. I apologize for my English, who are very poor. I hope my question...
Your face made such an indelible impression on me that I don't need your video on.
Sorry.
I'm saying I remember your face. There it is again. Okay.
Okay. Sorry. Yes, I have a couple of questions or remarks. I understand that in your work, you want, in the first part when you work on COVID-19, you want to see the second wave when there is no, when R is like, it's not transitory, it is a constant compartment. When you arrive, you never go away from this R compartment. But and I thought like this before when the COVID outbreak arrived. I was confident about the vaccination, and when the people get sick, they are protected for a long period. Mm-hmm. And what we observed, but it is that the protection is very transitory. And so the people don't stay in R compartment, and they go back to S very quickly. And I think this make and also the people who are the vaccination don't protect against the infection, but they protect against bad disease. Against the, but I think in your model we can add something like the people who get vaccine, they are confident that they are protected and they cannot be infected, but they can be infected.
Very nice.
And
go ahead.
And they also so I think it's like infectious status. There are two infectious status. There's the basic infectious status with no big disease, and the big disease. So they are in other condition. And I think this behavior is also the same for the people who get the COVID and said, okay, now I get the COVID. I don't have to be
right.
And they can be reinfected again. And one of my PhD students, she was vaccinated 3 times, and she get the COVID 3 times.
Right. Right.
So and this make me. So I was less confident about the fact that we can reach a high level of protection, and we said couverture, I forget the name in English. You know, it's when the proportion of S is equal to 1 on R0.
A herd immunity, yes.
Yes, and I'm wondering if we can reach herd immunity with COVID, because it's always a compartment who are start again to be S, and perhaps it's because we are coronavirus and other coronavirus, we are never protected. We get flu often because we are protection is not in sufficiently the level is not sufficiently high to protect according a new infection. We don't be very sick, but we are. So
that's a very nice idea. Very nice idea. Yes, in the model, there's no waning of immunity and no decay of vaccine efficacy. And I agree with you, a very nice idea, that people may feel overconfident in their immunity and return to circulation and get reinfected. Yes. I believe, I'm not sure I'm correct, and I would want to check that the probability of reinfection, having received a shot, is less than the probability of primary infection.
Yes, I think so.
So I think that's true also, which is a factor that you might want to include. But I agree with you, that mechanism alone could also produce, you know, some type of oscillation. Of course, the purely behavioral one, and I like this point very much. We should include that. In the case of 1918, of course, there is no vaccine, so those dynamics are purely behavioral. But I agree with you that in the presence of vaccine, yeah, right, overconfidence in sustained immunity could produce premature re-entry into the circulating pool and produce waves. I think that's a very nice idea.
Thank you.
Was there anything else? Did I miss? You made several points. Did I miss anything?
Perhaps we can exchange if you.
Yeah, I'd love to. Here's my email, please. I think that's great.
Okay.
How do you? I was curious whether you think any of this, since you're a veterinary person, how do you think any of this work connects to, diseases in animal populations? I remember Neil Ferguson as a colleague, and I remember the massive culling of sheep during, was it swine flu? I don't know, one of these animal epidemics. But does this strike you as having any bearing on animal diseases? I think it would bear on people who own the animals.
Sorry, my English is poor, so perhaps I don't understand very well your question. So I work on zoonosis disease, and COVID. It is, we can say, a mixed zoonosis disease, because we see it can manage very well without the animal department. The human is very efficient.
Yeah.
But also, this virus is also very efficient even in animal population, in wild animal population. So they found the virus in wild population of deer in America. Of course, in I forget the name of this animal. It's an animal built for the fur there is some farm of this animal, and they kill all these animals because they get sick, and also they can contaminate the human being with and as there are some markers that they are not the human source. But
I know what you mean. It's rabies, yes?
No, it was COVID.
COVID.
With the COVID, there is some example from human to animal and come back animal to human. So I think this makes this COVID even more complex.
Interesting. Yeah, I keep thinking, as I say, there was this mass culling of I think it was sheep during, that's what it was hoof and mouth disease all over England. And there was a massive culling of sheep. And I wonder, would that be, you model Agent Zero, where the threshold is, the action is to kill all the sheep, and the threshold is some level of,
Yes. It is the blue tongue. It was in 2000.
Yeah, something like that.
Yes, it's not blue tongue. It is I know it's fever afters.
Scotland or somewhere. Whatever. We're thinking of the same thing.
Yes. No, foot and mouth disease.
Foot and mouth disease. That's what it is. Yes.
I confused with another disease.
Yeah. Good. Those are all great thoughts. Thank you. I look forward to speaking further.
Another question in the audience? So there was a question in the chat. I will reformulate it. Yeah, so because Aziz has a question. So okay, please go ahead.
Please.
You're muted. You need.
Yes, I'm sorry. Okay. Thank you, Professor. What a beautiful presentation. Thank you
so much. I'm honored.
If I may.
Please. Thank you.
many questions, but I ask only one, if you follow me, related to the parameter and the real data. As far as I know, all questions related to fear, to panic, find a difficulty when we want to acquire real data. This, since it is related to the cognitive component, which is, as you know, very complicated to measure.
Of course.
For example, in a situation of panic of a population, for example, we can have videos recording the phenomena, even to have an idea of the tendencies of people who are really afraid, those who are less, etc., but not enough data to estimate the model parameters. For the fear of the vaccine, for example, in your work, I don't know, but it must be similar, unless you ask people the question, if, however,
they don't know anyway. They don't know
they
what
are afraid.
But they're terribly unreliable anyway. I mean, you ask people, what's your emotional state? I don't know what to make of it anyway.
Okay.
So, yeah. I mean, I think it's a real challenge, of course. And as I said, you know, there are some attempts to do this by mining Twitter, but of course that's obviously biased because not everybody uses Twitter, and the filters themselves are, of course, you know, highly questionable, and you know, all of that. There's some of this underlying neuroscience, and you know, the people doing neuroeconomics, they arrange these very, very confined lab experiments where they try to get at this. But again, that's a very, very unnatural setting, and it, you know, it's questionable how much that reveals about what people, you know, on the street in New York City are going to do. I agree that there are some interesting videos. I think of the stampedes at the Hajj and things like this, where people have tried to estimate something. I mean, what the heck's his name? There are all these people doing pedestrian dynamics using reaction diffusion models and agent-based models, where they try to replicate these stampedes and so forth. And I suspect you could extract something from that. But yeah, I mean, I think you know, I think it's a very difficult thing. Yeah. I agree with you. But you know, I think in the history of science, the theory often precedes the data. So, you know, and I'm not comparing myself to any of these people, but I mean, for example, you know, electromagnetic theory, Maxwell developed the theory long before, and it suggested that there are going to be radio waves, and then Hertz goes out and makes the measurement. And, you know, it's often the case that the theory, not that this has any remote comparability, but it often happens that, you know, in science, there's theory first and then measurement, and you help people figure out what they should measure. But I have to admit, I mean, it's not my not my strength. This is why God invented collaborations with empirical people. But you know, you're asking a deep question. I don't know the answer. I agree with you that it's difficult, and but I think lots of people are coming at it in different ways. You know, from the phenomenological part, trying to back out the parameter, trying to measure it with Twitter data or some other data, try to get at the sort of underlying neuroscience of it, and with some maybe experiments and reconstruction of observed panics. Maybe if we come at it in all these different ways, then some smart person will figure out a way to bound it at any rate and say, look, maybe it's between A and B or something.
Yes.
It's a bad answer to a great question.
Thank you so much.
We have another question.
Sure.
Yeah, there was a question about because you mentioned I think this word always catches attention. So you spoke about irrational. So there is a question about that in the chat. Maybe I will reformulate it a little bit. So yeah, but still, you're right. But it's irrational in terms of gain and benefits. That's right. And meanwhile, the mechanisms, there are some, should I say, causality, meaning that even in our people around us, yeah, you can understand the causality behind that. The fear, yeah, people get fear of the consequences of the vaccine and the media, and so the question is could fear be irrational or complex? Meaning that there is a causal, my interpretation of that, but there is causalities about that. There is clear mechanisms, but of course people are not acting in their best interests, and they are, yeah, subject to emotions.
Well, this is, I mean, okay, so if you talk to a really orthodox rational choice advocate, they would probably say the fear is part of their utility function, and given the fear, irrational as it may be, they maximize utility. So now, two answers of this are, that is not what's observed in humans, in the data, or in laboratory experiments. But more importantly, they're sort of insisting that, look, we don't care about whether the preferences or attitudes or any of this stuff is crazy. We just care that given the crazy beliefs you have, you optimize your utility function. Of course, utility functions can't be measured either. And there's such a vast menagerie of them, you can pick a utility function that will make any behavior optimal. So it's either already falsified or not falsifiable, because anything can be made rational if you make assumptions about nutty preferences or changes in the circumstances or all of these other things. So I have other thoughts on rational choice, but what they're saying, do you care about how people come to these crazy fears or not? If you do care, then rational choice, by their own insistence, offers no insight. They're saying we don't know about it, don't care about it. It comes from somewhere we're not interested in. But I am interested in where it comes from, and I am interested in how these pre-rational or not even conscious, much less rational attitudes, fears, affect, emotions, conformity effects, all of this other stuff happens in humans. So mainly they're just saying, we don't care. And we're making this bold assumption that whatever the hell is going on, people maximize utility subject to it. To which I answered, that's really been threatened by a series of Nobel laureates in economics. Herb Simon, Kahneman, all these other people have said, that's just not how it works. And we have all these fallacies and biases and endowment effects and anchoring and base rate neglect and all this other stuff that we've established violate the axioms of rational choice. And they can say, well, that you got the wrong utility function. Well, okay, but then it's not falsifiable, because I can always reverse engineer utility function with respect to any x is arg max u. So it's either falsified or unfalsifiable, or to be fair, applies in a very, very restricted range of settings in which pandemics probably don't belong.
Yeah. So another remark, going back to the estimation of your parameters. Yes, I would say so. Of course, there's a bunch of mechanisms and causes that results in the numbers, but the ultimate choice, and I think that's the IA choice. But at the end of the day, you are able to fit the data with your so we know how many people are taking the vaccine and how many people. So that's a good insights, and from then you can I think in this setting, it's also an inverse problem to get the number of fear from the adjustment to the data. And
right. And in the paper we look at their whole, there might be many parameter combinations that produce the observed dynamics. So we have several graphs where it's one axis is disease fear, the other axis is vaccine fear, and there are regions of that two-dimensional space that generate the dynamics. So it's a problem, again, it's, high dimensional systems, not terribly high, but high enough to be a problem. But yeah. And I welcome obviously I'd be thrilled at better, empirical methods. Please don't get me wrong. I don't mean to denigrate data. It's crucial. It's without data, there's no selection pressure on the theories. So nothing can develop without actual data.
I think we really appreciated your talk, which is really for us mathematicians and gives very good insights about real questioning in society, and you were able to putting that in math, and that's a very interesting insights for us.
Well, I'm delighted and honored that some of you at least may feel that way. That's my only real hope. And I welcome collaborations with everyone, as I say. I think, what happened in mathematical biology is mathematicians and physicists invaded the field, and it evolved from the sort of systematics and cataloging of direct observation cataloging into something legitimately theoretical and interesting. And I think much of the social sciences, which I broadly define to include behavior and epidemics and risk, is really ready for the same thing. So I think we should join forces and invade those areas as well. But as I say, I'm very honored that you enjoyed the presentation and think this might be a fertile direction.
So maybe I think we should stop. I will thank again Joshua for his very nice talk. I will thank the president of French Society Speaking Theoretical Biology for his support.
Thank you. Is that Aziz? Or
this is Jean-Pierre Françoise.
Jean-Pierre François. Thank you, sir.
Yeah, very good mathematician, interesting in the biology.
Great.
Comes from pure mathematics, and he actually has a book, a very nice book, but it's in French. I think I never found it in English, but well, a lot of works.
Great.
Yeah, on oscillatory mechanisms.
Wonderful.
Biology.
Wonderful.
Yeah, very nice. Aziz is the director. Again, I thank him for his support also in all these international
wonderful.
Initiatives.
Great to meet you all.
Yeah, he's the director of our lab, and actually he's vice president of our university. He's a very busy guy.
Forget it. It's not.
Oh, God. Sounds horrible.
And yeah, thanks again for everybody coming in from.
Terrific. Please consider me a member of your collective if I qualify. I think of you all as colleagues. So
yeah,
look forward to more.
All right. So thank you so much. So this video will be put on media, and so I will advertise on that. So thanks again, Joshua.
Wonderful. Thank you all. Nice to meet you, and look forward to further contact.
All right.
My pleasure.